PU2 aspirants. So yes, I know all of you would have almost completed your preparatory exam, and the Bangalore South students would have written their chemistry preparatory exam yesterday. Okay, so I went through the paper, and the paper was not very difficult. It was a moderate paper, I can say, and I'm glad to see that if you would have followed my Brahmastra series and decode NCERT, almost 42 to 44 questions you could have attempted out of 46 questions. I can tell you the guarantee, and I will show you also that where I have discussed those questions, which I have taken screenshot and given you to give you that trust that Brahmastra series will really be helpful for your PU2 preparation. Okay, now let us have a quick analysis of the paper. So if you see here, first let us talk about the section B. Okay, I'll come to section A little later. Section B, if you see question number 21, 22, 23, 24, 25. 5 questions were there, and you have to attempt 3 out of 5, right? And here the pattern, so the whole entire question paper followed the blueprint. Okay, so there were 3 blueprint, any one of that matched with this. So, and you in this section B, you will have 5 questions. 1 will be from haloalkanes, 1 will be from alcohols, 1 will be from your biomolecules. From solutions chapter, there will be 1 question either from kinetics or from the solutions, from physical chemistry. 1 question will be either from kinetics or from solutions. Similarly, from inorganic, it can be either from DNF block or from the coordination compounds chapter. Now if I see, these first questions were super damn easy. Now DNF block question was little difficult, so that was a little unexpected question, and if you would not have read the entire textbook, then you might not be able to answer this particular question. So now if you see, you can easily attempt 3 questions, and 3 questions will give you 6 marks, so 6 out of 6 you can easily get from the section B part. Now coming to section C, it also has 5 questions, okay, 1, 2, 3 from 26 to 30, but these 5 questions are from inorganic chemistry and they carry 3 marks each. Now here what you have to do, here it is like 2 plus 3, it can be 2 questions from DNF block and 3 questions from coordination, or it can be 3 questions from DNF block and 2 questions from coordination, right? So in this paper we saw 2 questions from DNF block and 3 questions from coordination. The other 4 questions were very easy, but one of the question from coordination compounds was asked regarding the stability of the complex. So in the recent the new chemistry book, the coordination compounds chapter, stability is not covered. It was there in the earlier NCERT book. So old NCERT book you can find that concept, but anyways this question was asked. I think this question is little bit out of syllabus, but yes, we can discuss the answer for that question as well. Now coming to the next, physical chemistry, 4 questions. Here the pattern is 2 electrochemistry, 1 kinetics and 1 solution. The same pattern was followed. And electrochemistry questions were a little moderate and difficult, I can say, and chemical kinetics question was super easy, and solutions question was also moderate, not very direct question. So you can easily aim 4 to 5 marks in this. So, and 6 mark is also possible if you have read the solutions chapter correctly. So assuming you will get 4 to 5, so if I add here, you will get 9 plus 16. Okay, 9 plus 6, 15, sorry, and here if you are getting 5 marks, 15 plus 5, 20 marks you have got here. Now coming to section D, okay, so we have got how many marks in the previous, so including section B plus C, you can easily score 20 marks, okay. Now coming to section D, mine's question was little moderate, okay, although it is a direct question, but the compounds names are given in the form of A, B and C, so that way it makes the question little bit tricky. Aldehydes, ketones and carboxylic question, one of the question I will target it as difficult. Biomolecules question was very direct and easy. Haloalkanes was also easy question, and alcohols, phenols also there was easy question. Aldehydes, ketones, this was moderate question. So I think this 3 questions, 1, 2 and 3 you can easily attempt, okay, and if you can attempt these 3 questions, so you will get 15 marks, and you can attempt any of this, so I am assuming you can easily get 18 marks from here, okay, because 3 questions were very direct, right? So I told you that if you read these 3 chapters, that is your haloalkanes and alcohols and aldehydes, ketones, then you can easily solve the questions from here as well, so you can get 18 marks from here. Okay, so around 38 marks we got here. Now coming to numericals, except one particular numerical, that was the second question, I think 42. Other all questions were direct and very easy numericals. Easily you can score 9 on 9. So so we have 38 plus 9, so that is 47 here. Okay, so we have almost got 47 here. Now 5 marks fill in the blanks all of you will get, I think that is also there. So we have also got 52 marks. So now if you just need to get 8 marks in your fill in the blanks, so get 60 plus out of 70. Okay, so if I see now the chapter wise the MCQ question, so question number 1 to 10, I find that there were 1, 2, 3, 4 and 5 and 6 easy questions were there. Okay, and here also 7, 8, 9, 10, 11, these all 11 questions, 11 you can easily score, means 11 plus 5, 16. So I believe that if you had read properly and followed my Brahmastra series and Decode NCERT series, then 16 out of 20 here is very easily possible. So now here we have got 52 and here I am getting 16. Okay, so okay, sorry, not 16. So I have got 47, right? So I am not counting this one. So 47 plus 16, so that is around 63 marks is bare minimum you can get if you have followed my Brahmastra and Decode NCERT series. Now let us start with the questions. The first question here was, see, you can see the first question, a liquid mixture was mixed with methanol and heated with concentrated sulfuric acid as a catalyst and a dehydrating agent. A compound with a fruity smell was formed. So whenever you think the fruity smell is there, it is nothing other than esters, and you have already taken one alcohol and ester is forming, so the other compound has to be an carboxylic acid, right? So the liquid was carboxylic acid, that is your option number C here. Now coming to question number 2, the bad odor substance formed by the action of alcoholic caustic potash on chloroform and aniline is. So this is your isocyanate test for the test of primary amines. So that is your phenyl isocyanate, that is option number B. Okay. Next, this is also a very easy question, glycosidic linkage. You know, you just connect how when you do glycosidic linkage you write like this, right? So this side R and this side R, in the middle there is one oxygen, so that is ether linkage, option number C. Here many of you might do the mistake of ester linkage, but remember it is ether linkage. So I feel all these 3 questions were very easy, so we can get 3 marks here. Next, moving, this question I feel was difficult because if you haven't studied if you had watched my Decode NCERT series, I have discussed there, but anyway, if you haven't read the applications part properly, you will not be able to answer this question. So this was, I can say you might get wrong this question. So rhodium complex is the correct answer for Wilkinson catalyst. Next, freon can be prepared by, this question was there in your midterm paper as well, okay, and it is prepared by Schwartz reaction, and I will consider this one also easy question. So actinoids are radioactive, having smaller lives and prepared in nanograms. There is a question in the midterm paper also, why actinoid study is difficult. This question I have discussed in my Brahmastra series as well. So if you can see, this one will be all of the above. So this is also easy question. Now which of the following compound will have the smallest pKa value? So if you see, benzoic acid, acetic acid and phenyl acetic acid and formic acid. So formic acid does not have any group, there is no electron releasing group, so that is why that will be more acidic. So it will have the, okay, smallest pKa, that means more acidic, so option number A. So this question also I can consider little bit difficult. So from this question I can say you can easily get 2 marks, okay. So first 3 marks, here 2 marks. Because I am considering this question you may get wrong, this question you may get wrong. Now question number 8, the rate of reaction, that is A to B, increases 2 times by increasing the concentration of 4 times. So I can write like this, R is equal to K into A to the power of N first, okay. Now second time what I am writing, rate of the reaction increases 2 times, okay, K into, when the concentration increases 4 times, right. So this is equation 1 and this is equation 2. So if you divide this one, it will become 4 to the power of n, and I can write 2 is equal to 2 to the power of 2n. So I can write 1 by 2 is equal to n. So n is equal to half order, that is an easy question. Next, the specific conductivity decreases with dilution. The number of dissolved ions per unit volume increases on dilution, okay. So here what happens, the specific conductivity decreases on dilution. This is true. Okay, now why does that happen? Because the number of dissolved ions per unit volume also decreases. Okay, so assertion is true but reason is false. So option number C. Here I can consider the first question was easy, so we will get 1 mark. This question you may get wrong, so I have till now we have got 6 marks. Okay, next coming to 10th question, find out the product. So this is very simple question. You know, at very high temperature and pressure, OH can replace this one, that is your Dow's process. So we will get here option number C. So this one was also easy question. Okay, so 7 marks we got. Desalination of seawater can be done by reverse osmosis. I think all of you know this. 8 marks already got now. Next, the KH value of argon and all are given, the order of their solubility. So we know that KH is inversely proportional to solubility, right? So if I just mention, this is also easy question. So if I see what is the value of argon is 40, if you just see, argon has the highest KH value, so it will have the least solubility, right? Least solubility, you can find only one option, so we can eliminate this too. Now here there is a change, you can just compare CO2 and CH4. CO2 value is 1.67 and CH4 is 0.413. So this one will be more soluble, right? So CH4 will be more soluble than CO2, so option number C. Okay, let me just write down once again and confirm. Argon is 40.39. Then we have CO2. This question we have done in case set, we have done in so many times this question we have done. Okay, so CO2 is 1.67, this is 1.83 into 10 to the power of minus 5, and this is 0.413. So this is the least value, so it will have highest solubility, that is there in these two options. And then we have this one, and if you compare, 1.67 is more, right? That means solubility of CO2 will be less, that is the option number C. Okay, so this is also easy question, 9 marks. Next we have, here I have given you 2 marks, right? So how much we have scored till now? 3, 2, 5, 6, 7, 8. Okay, this one 9. And phenol on oxidation with chromic acid, this is also direct question, benzoquinone. Okay, you will get 10 marks here. Next, moving, 10 marks we have already got. Now from amino acid, this is also easy question because match the following, right? You can eliminate very easily here. Optically inactive amino acid, we all know it is glycine, so A has to be 1, and there is only one option with A is equal to 1, so that is why here also it becomes easy. Okay, so 11 marks. Next, the crystal field splitting energy in octahedral is greater than the pairing energy than the ligand forms. So if crystal field splitting energy is higher, then pairing will takes place, and if pairing will takes place, spin will be less, so it will form low spin complex. And I think here is little difficult question, so this one you may do it wrong, so we have got 11 marks. Okay, now coming to this one, this is very easy, you just have to match highest oxidation state in 5D series. So you can see only one element is there, so there is no choice, you know which is, so there is only one element, so this one has to be osmonium, so you will get 11 marks, 12 marks we got here, right? Next, chemical name of Hinsberg reagent, benzene sulfonyl chloride, this is your 17th answer, so you got 13 marks. Okay, next we have mixture of chloroxylenol and terpenol is called. So this is also not there in the book, but if you see the options, you can easily find out it has to be Dettol, right? So we'll get 1 more mark. So this is your 18th one. Next, people taking lot of salt, that is your edema, 19th mark. So this is your 19th question, ozonolysis of alkenes. So here we have just left with anoxia and aldehyde, so it has to be aldehyde. So how much went? 5 marks. So total 17 marks we got in section A. Okay, so I will write here section, one second. Okay, so I got 11 marks here and 5 marks. So total 16 marks I got out of 20 in section A. Means easily I can get 16 marks from here. Okay, if you are getting less than this mark, then you haven't followed my series properly. Okay. Next, coming to part B. Okay, so there are 5 questions and you have to answer any 3. The first question, Sedzeff rule with an example. This is direct question, you can easily get this question. Next, glucose biomolecules reaction. This is also very easy question, direct question. Next, This question, I feel 23 question chemical kinetics was little indirect, but again I have discussed this exact question in my Brahmastra series as well. Here this question was easy and this question was little difficult. So if you have to answer easy 3 questions, then I can suggest this one was easy, this one was easy, and this one was easy. Okay, and these 2 were little moderate to difficult questions. Okay. So let us come with the first question, that was your Sedzeff rule. So you can see in my Brahmastra series day 1 of PU2 haloalkenes and haloarenes, I have discussed this question. Explain Sedzeff rule with an example. Okay, so that is there. So what happens during dehydrohallucination, more substituted alkene is formed as the major product, but you also have to give an example here. So if I just put one example, dehydrohalogenation, right? So I can put CH3, CH2, Cl, CH2, CH3. Okay, one second, here it will be CH. Okay, so now what I'll do, if I do alcoholic KOH, okay, HCl will be removed and we will get, so Cl can be produced here also, or this HCl can also be removed, this HCl can also be removed, but we will form more substituted alkene, so I'll get the product like this. Clear? Next, question number 22 was your structure of glucose, right? So this was also discussed in my Brahmastra series. So I've taken a snaps and I've put down so that you can trust me and you can just believe that Brahmastra series, as I've always told you, will be really helpful if you do all the questions from there. So you can see how do you know that glucose has 6 carbons in a straight chain and you have here 5 OH groups. Both the questions have been covered. So here for 6 carbons, this one is the answer, you have to react with HI, okay, and for 5 OH group you have to react with acetic anhydride. Okay. Next, question number 23 was your Arrhenius equation. Okay, so what were the postulates of Arrhenius equation, and you have to explain it using a potential energy diagram and taking HI as an example. So first of all, many of us get confused with collision theory and Arrhenius theory. Okay, so Arrhenius theory is there in your NCERT book and it has 2 important points. What does Arrhenius theory says? So according to Arrhenius, the reaction can take place. So this question is not very direct because we get often confused with collision theory and Arrhenius theory. Okay, Arrhenius theory separately is given in your NCERT book. So according to Arrhenius, it's not given, sorry, it is not given separately, it is there in that paragraph only, so we miss it. But yes, here there are 2 important points. According to Arrhenius, the reaction can take place only when reactant molecules collide to form unstable activated complex. It exists for a very short time and breaks up into to give you a product. So Arrhenius theory says that whenever 2 reactants react, they form an unstable intermediate and this intermediate gives you the product after some time. Okay, so you can see example, if you see H2 and I2, so H and I when they combine, okay, this is the intermediate formed between them. Okay, so Arrhenius theory tells us that there is a formation of intermediate and after that we get the products here. So Arrhenius theory says that there is a formation of intermediate in a reaction. Okay, so what happens when these 2 reactants react, there is a formation of intermediate and after that we get the final product formed here. Okay, now you also have to draw a diagram for this. Okay, so there is slight flickering in the board. Okay, that may little disturb you, but yes, let us continue the class with this. So the diagram you can see, it is the H2 and I2 diagram is there, reactants are there, one activated complex is formed and then a major product is formed. Now here there is something which is your we can say the transition or the intermediate is formed here. Okay, so this question I can say most of you might not have studied from NCERT book, you might have left it, but yes, if you would have watched my Brahmastra series, I have done that question in this particular chemical kinetics channel video. Okay, now you can see the same question. Okay, fine. So now moving to the next question, that is question number 24. Okay, so that was a reaction based question and it was an easy question. So let us see this question here. 24. Okay, so you have to complete the following: copper with 573 Kelvin and C6H5OH with zinc dust. So we know this one will convert to secondary alcohol, right? It will get converted to ketone. Okay, so we will get acetone or propanol, and here phenol with zinc dust will give you benzene ring. So that will be the answer. So I will directly write the answer here. You just have to mention the products. You do not have to write the reaction mechanism or anything in this question. So what basically we will be getting, 24A will be your propanol, okay, and 24B will be your benzene ring. Okay, now coming to question number 425. See, actually this question is not difficult, but again, if you have like learned the book, then it is very easy. So the question says that, let us see the question once here. Yeah, see, name the oxometal ions of the first series, that means of the 3D series, in which the metal exhibits the oxidation state equal to its group number. Okay, so now if you see here, this question, the metal oxidation state should be equal to its group number. So if you see scandium, okay, then we have titanium, vanadium, chromium and manganese. Group 3, group 4, 5, 6 and 7, right? The highest oxidation state should be equal to the group number. So you know titanium can exhibit +4 state, vanadium can exhibit +5, chromium +6, this is +7 and this is +3. Okay, so that is what they are equal to the group number. So you have to mention these ions, any 4 you can mention. Okay, next, so we are done here with the 2-marker question. Next we'll go to 3-marker question from the inorganic chemistry. So how is potassium dichromate prepared from the chromite ore with balanced equation? This is important. When it is asked balanced equation, you have to balance it, and I know this is little difficult question, means it is a very direct question, but remembering this answer is difficult. So what you can do is write down it in some short notes, paste it somewhere and try remembering this reaction as many times as possible. Okay, so this was a very easy direct question. Next, on the basis of valence bond theory, explain the hybridization. This was also easy question. 3 + 3 6 also you can get. Now what is lanthanide contraction and give any 2 consequences of it. This is also easy question, so you can easily get 9 marks here. Next we had what is meant by stability of a coordination compound in solution, state the factor which governs the stability. This question, as I stated in the starting of the class, it was there in the previous book. In the current book there is no word stability in the entire textbook, okay, in that entire chapter, but still we can write the answer for this one, I'll tell you. Next we have draw the geometrical isomers. This also I have discussed, and there's a question, what is density in coordination compound, and I truly believe 100% that there is some printing mistake here. It might be denticity about which the question was being asked, okay, because this density word itself is not there in the whole chapter. I have read it word by word, okay, so that is why you can think that this might be about denticity. Okay, so assuming that, I'll be telling you the answer. So first 26th question, this question was also there in my Brahmastra series. I have discussed it, all the 3 steps with proper balancing you have to write. First, iron chromate is converted to sodium chromate, sodium chromate is converted to sodium dichromate, sodium dichromate is converted to potassium dichromate. That was your question number 26. Next, moving to 27, the NiCN4 diagram. So I have discussed a similar question for cobalt NH3 6 3+, and I have also told you that you can write down the same way for COF6, NiCN4 and all I have discussed. So how you can do? So the first thing is NiCN4 2-, right? So first you need to write the nickel oxidation state, that is 2+, so its electronic configuration is 3d8 and we get a configuration like this, 5, 6, 7 and 8. Now next point you have to write is Cn- is a strong filled ligand, so pairing takes place. Okay. Next, what you have to do? You have to show that with pairing. Okay, so here what will happen if pairing will take place? We will have like this 3D, and we have 4s, and here we have 4p. Okay, so now if this one is there, okay, so what I will get? DsP2 hybridization. Okay, now if DsP2 hybridization is there, we have Cn minus, Cn minus, Cn minus, and Cn minus. So these ligands will donate electrons here. Okay, so now what I can say, what is the hybridization? Hybridization is DsP2, and if it is hybridization, what will be the geometry for DsP2? It is square planar. Now if it is square planar, what will happen after that? Magnetic property, you can see there is no unpaired electron, so it is diamagnetic. Right, so this one, if alone you write, then you won't be getting the marks. You have to write the explanation, and then you have to write the hybridization geometry and the magnetic property. Okay, next, moving to question number 28 about lanthanide contraction. This question was also discussed in my DNF block chapter. I have discussed this question in detail. What is lanthanide contraction? Give any two consequences. So you can write down, it is a steady decrease in the ionic radius from lutetium to from lanthanum to lutetium, and what are its consequences? It is difficult to separate them because of the similar sizes, and the basicity decreases from lanthanum to lutetium. Okay, so definition and two applications will give you 3 marks in total. So this 26, 27, 28 easily you can answer, and 9 marks you will get here. Now coming to this 29th question, which I was telling you about the stability. Okay, that was a difficult question, and that is not there in the book as well. So let me first understand what is the stability. Stability means, stability you can write down, stability is the strength of bonds between the metal and ligand. Stronger the bond, stronger the bond, stable is the compound. Okay, next, how it is denoted? It is denoted by 1 by Kf, where Kf is equal to formation constant. Okay, so this is all about, you have to write what is stability, or what do you mean by stability of coordination compounds. Okay, so if the compound cannot break easily, then it is more stable. On what factors it depends? I'll be telling you 3 factors. First is size of the metal. Okay, so small size, then more strong bond. Okay, next, charge of the metal. Okay, it's also more charge, more stable. Okay, third is chelating ligands. If there are more chelating ligands, it will be a cyclic structure, right? So it will bind properly, and that is why stability will be high. So these 3 points you can write down. So I want all of you to take a screenshot of this or note down these answers, because this is not there in your book. Next, coming to 30 question, that is you have to draw the geometrical isomers of this one. So exactly I have discussed this form ML4X2 type, right? So this is your ML4X2 type. You have to draw the cis and trans form of this one. So you can easily draw this one. So if you have Fe, okay, 4 Cn on the 4 side, or I can say 4 Cn on the plane, and you have NH3 here and NH3 here, and that is your transform. Okay, and now cis one will be what? You can just change it like this. You have NH3 and you have NH3 here, you have Cn here, Cn, Cn and Cn. Clear? So this one will give you cis form. Now what is the question? What was density? That question, I feel it is denticity, and the definition of denticity I have told you while discussing my decode NCERT. I told you to focus on this word denticity. Okay, remember its definition. So that is what is there. The number of ligating groups in a ligand is called as the denticity of the ligand. Okay, so with this we are done with the section C, part volume is where the 3 marker questions from inorganic chemistry is asked. Now coming to the 3 marker questions from physical chemistry. Okay, so this section in the midterm paper was also little bit tough, I found, and electrochemistry questions are generally tough in this part. Okay, so the first question is from electrochemistry. Explain the determination of standard reduction potential value of zinc electrode by using SHE as a reference electrode. Okay, this question is something which you might not have expected at all. Next question, derive the integrated rate equation of the first order. This is expected and direct question. This you will be able to write. So 3 marks you can easily get here. Next, explain the rusting of iron is an electrochemical phenomenon. So this one is also a little difficult question, but yes, if you have studied, I have discussed this one. If you have studied this one, then this reaction is fine. Next, give reason for the following. Scuba divers fill the air cylinders with helium. This one you can answer. Next, addition of small amount of salt in water decreases its freezing point. I feel this one you might be knowing, but you to explain it, to write the explanation, it might be little challenging. I value for aqueous KCl is more than ethanol in benzene. So this is also easy. So here 3 and here 2, because this one is easy, but to write that answer to make the examiner understand, it is little difficult. So 3 plus 2 you can easily get 5 marks here. Okay, so let us see the first one. This question, but yes, this question I have discussed in my Brahmastra series, how to determine the SRP of copper electrode using SHA, and in the question it is asked zinc electrode. So very same answer you have to write down. Okay, so first you have to take a standard hydrogen electrode and you have to connect it with the zinc rod on the other side, and the difference value, whatever is asked, whatever is read, that will be the value of your zinc rod. Okay, so that is what you have to write down. Next we have integrated rate law derivation. You can see this question all of you would have done it. I hope that it is direct question, you know how to write down the answer. So derivation, please check here. I am not going to explain it because I have done it many times. Next, this question, what is rust, and give its formula. So you can see this question was also given. Explain corrosion of metal, or explain corrosion is an electrochemical phenomenon. Okay, so this question I gave you, and this was also discussed in Brahmastra series. So yes, this question is also there with you. Okay, so you can just write down here. So now coming to the next question, that is your question number 33. Okay, so here it was that rust is a phenomena. So let us see what was the question exactly. So the question was rusting of iron is an electrochemical phenomenon, explain it. Okay, so this question I have also explained in my Brahmastra series. Okay, so you can see this one. Yeah, so this question is there, explain that explain corrosion is an electrochemical phenomenon. Okay, explain the mechanism of rusting of iron. So this was also there in my electrochemistry Brahmastra series. So answer is very simple here. At a particular spot of an object made up of iron, oxidation takes place, and at another place reduction takes place. Okay, so we can write the reaction for oxidation. 2Fe releases 4 electrons to get converted to Fe2 plus. Okay, so if it is not clear, let me write down here like this. So where oxidation takes place, right? At anode. Is it visible red color? No, let me change it. Okay, so what happens at anode? 2Fe loses 2 electrons and becomes 2Fe2 plus 4 electrons. This is done. Next, what happens? Electron release at the anodic spot move through the metal and go to the another spot of the metal and reduces the oxygen in presence of H plus. So what happens here? They at another point at cathode, what will happen? This electrons, okay, moves and reduces the O2. Okay, and we have also taken 4H plus here. To give you what? We will get 2H2O. Okay, now if you add these two reaction, what will be the final reaction? That is 2Fe, okay, plus we have 4 electrons will get cancelled, so we have O2. plus 4H plus, that will give me 2Fe2 plus. Okay, then we have 2 water. That is the final reaction. Okay. Next, moving to question number 34. So what was the 34 solution? Chapter 3 questions were there. First one, why scuba divers use helium? That is because of low solubility of helium in the nitrogen gas. So this question I have explained here. Okay, how it is controlled in regarding bends, but yes, answer is same. Next question, why the freezing point decreases on addition of a solute? Here I want to explain this properly. Now see, a solution will freeze when its vapor pressure equals to the vapor pressure of the pure solid solvent. Okay, so solution vapor phase and that solvent vapor phase in the solid phase, if it is equal, then the liquid will so if you can see here, see, suppose I have the vapor phase of the solvent, okay, and we know that solution vapor phase will be less than that. Okay, now what will happen? Now suppose this is the point at which the solvent is having a freezing point like this. Now you have to match this one, so you have to go what? Backward. So your freezing point of the solution will decrease. That is what happens in case. So according to Raoult's law, when a non-volatile solute is added to the solvent, its vapor pressure decreases and now it would become equal to that of the solid solvent at a lower temperature. Thus the freezing point of the solvent decreases. Next question was regarding your I factor of KCl and ethanol. So KCl will dissociate to give you K plus and Cl minus, so its I value is 2, whereas ethanol does not dissociate and its I value is 1. Okay, so that is about your physical chemistry questions. Now we will move towards section D, where we have, so yes, you can see this freezing point concept I have discussed in my decode NCERT type. Okay, how to write the answer I have highlighted and told you. So if you had followed my video, then definitely, and you can see here I have written this particular question, why freezing point decreases on addition of solute. Okay, that particular question also I mentioned you. Fine. So next, coming to the 5-marker question, the first question is an aromatic compound A on treatment. So what is the pattern here? I'll tell you. There will be 6 questions. Okay, 5 questions will be there from the 5 chapters, and aldehydes and ketones will have 1 more question, means 2 questions from aldehydes and 4 questions from other 4 chapters. So the first question was from amines chapter. An aromatic compound A on treatment with aqueous ammonia and heating forms a compound B. Okay, so if I write down here, yes, so we have an aromatic compound A. Okay, on treatment with ammonia forms a compound B. So A is there, and if you are treating it with ammonia, you are getting B. Okay, B on reacting with Br2 and KOH. So if you have seen this reaction Br2 and KOH, it is nothing but Hofmann bromamide degradation. That means this had to be an amide group, and if you know, if you react acids with NH3, you will get amide group, right? So forms a compound C. Okay, now C is having the molecular formula of C6H7, so that is definitely your aniline group. Okay, and this one is your amide group. I can write like this, and this one is your carboxylic acid group. Okay, so what will be the products here? A is, what you have to write? Write the structure and the IUPAC name. So A I have already written, so that is your benzoic acid. Okay, next B is benzamide, and C is aniline. Okay, so writing these 3 will give you 3 marks. Next, during the reduction of nitro compounds to amines, scrap iron and HCl is used. Why? So this question also is little difficult, but I have explained in my video. You can see that during the reduction of nitro compounds to amines, scrap iron and hydrochloric is used. Give reason. So I have explained this particular question. So that is what happens when you use Fe and HCl, okay, iron scrap and HCl, you form the byproduct FeCl2. Now this FeCl2 again gets hydrolyzed or reacts with water to give back HCl, okay. So that is why with little amount of HCl the whole reaction can be done. So that is why we use or we prefer Fe with scrap HCl. Next question was your solubility decreases with the increase in molecular mass. So this question also I have discussed here, solubility, you can see exactly same question. So that is due to the increase in the hydrophobic part, okay. Next, coming to question number 35, okay. So with respect to the structure, with respect to the carbonyl structure, give the following information: hybridization of carbonyl atom, alpha, sigma and pi bonds, and the geometry and the bond angle. So if you see here, yes, so this question you can see in my decode NCERT part, I have explained the hybridization, bonding and everything. So that is sp2 hybridized, and if you see the carbonyl compounds are like this, right? So we have 1, 2, 3 sigma and 1 pi bond, and what is the structure? It is trigonal planar and the bond angle is 120 degree. So this will carry again 3 marks, 1, 2 and half of 3 marks. Next, by side chain chlorination, if you know CH3, if you just treat it with chlorine and HCl, all this will get converted to Cl. After that you just treat it with water, all will get converted to OH, and then they will undergo tautomerization to give you CHO. Okay, so this was also easy question. Next, 37 question, that is your draw the Haworth structure of maltose. You can see I have given you the same question. It has been a very important question and a repeated question. Name the types of bases present in nucleic acid. That question also I discussed in the Brahmastra biomolecule video. And write the structure of zwitter ion. That also I have discussed with you. Okay, so here let me tell you the answer for them. Maltose structure is like this. I hope all of you can see. Okay, so here there is a alpha D glucose unit and alpha D glucose unit. There is a glycosidic linkage between C1 and C4. This is part A. Okay, now this one will give you 1 mark. Next question was what? The bases. Okay, so what are the bases? So it is B. DNA has adenine, guanine, thymine and cytosine, and RNA has adenine, guanine, uracil and cytosine. So this one will give you 1 mark, this one will give you 2 marks. Okay, next question was zwitter ion. So write the zwitter ion structure for glycine. 1 second, yes. So if you know what is zwitter ion, so you have to explain and you have to write the structure. So in aqueous solution, the COH group donates a proton and the amino group accepts the proton, giving rise to a dipolar ion known as zwitter ion. Now if you draw the structure, how will it look? You have COO minus, you have NH3 plus, you have one side R and you have one side H. This structure is your zwitter ion. Now moving to question number 38. So explain the mechanism involved in the conversion of tertiary butyl bromide into tertiary butyl alcohol. So this is SN1. So this question also I have discussed, very similar. Okay, so first of all what happens? Step 1 is your formation of carbocation, right? So here how should you write? 1 second. One second. So first of all is we have to write the reaction exactly. So what is happening here? Tertiary butyl bromide, right? So the reaction is like this. So the reaction that takes place is like this. Okay. Now if you want step 1, step 1 is what? Step 1 is formation of carbocation. Okay, so here what happens if you have this CH3 Br, so that will remove this Br. Okay, you can just put an arrow like this and you can see here and plus. Okay, next step 2 will be what? Attack of nucleophile. Okay, so here you can write down like this. So you have a plus charge here and then OH minus is there, OH minus will attack here and you will get the desired product. Okay, so this is very simple. So 3 steps you write the first reaction and 2 steps, it will give you 3 marks. Next, explain butane 2-ol is chiral and optically active. So you have to explain why it is chiral and why it is optically active. So if you see butane 1-ol, okay, so butane 2-ol, this is the structure, right? Butane 2-ol. So you can see why it is chiral, because butane 2-ol is chiral because it has a carbon which has 4 different groups attached, right? And now why it is optically active? It is optically active because it is able to rotate the plane polarized light. So here you will get 2 marks. Okay. So with this we are we have 2 more questions, sorry. Now write the chemical reactions to affect the following transformation. Butane 1-ol to butanoic acid. So the first one you have to just use simple butane 1-ol to butanoic acid. So what is this one? This is KMnO4. Okay. Now coming to the second one, cyclohexene to hexane 1,6-dioic acid, right? Cyclohexene to hexane 1,6-dioic acid. Now what is the reagent? Here also you have to use KMnO4. Okay. Next, third one is butanal to butanoic acid. So you have butanal to butanoic acid. Okay, so this one will be oxidation. You can use any oxidizing agent, you can use same KMnO4 as well. Okay. Next, explain Clemmensen reduction with an example. So this is question, I think very easy question, we all have discussed, many of you already know. Reduction of aldehydes and ketones in presence of Zn or HgHCl. So that will to give alkanes. So you can just complete it, to give hydrocarbons. Okay. Now if I want to write the reaction, so CH3 double bond O, CH3, presence of zinc amalgam, okay, HCl will give me right. So that is your option B, or sorry, question number B. Okay. Next, question number 40 is write the mechanism of dehydration of ethanol to ethene. This is also very expected and direct question from the alcohols chapter. You can see this question I have discussed many times. So first step is the protonation of the alcohol, then second step is the formation of carbocation, and third step is the formation of ethene or elimination of the proton. Now this question was little tricky, but do not worry, I have discussed the same question. Okay, this was hydration question which I have explained in my alcohols Brahmastra video. Okay. And the second part, that is what happens to diethyl ether when it is heated with limited amount of HI and excess of HI. Same question was also discussed in your alcohols, phenols, ethers chapter. So diethyl in the question given in the question paper is also diethyl ether. Okay. So if you treat it with limited HI, first one, limited HI. So what will happen? Bond will break, one will take H, one will take I. So the product formed here will be C2H5OH plus C2H5I. Okay. Now the second one is excess of HI. Okay. So now what happens after this one? This is formed. Now if you add more HI to this one, what will happen? See, this is like this, and you have added more HI. So first this one will get protonated. Okay. Now once this is protonated, I minus is there, it will attack and this one will leave, and you will get C2H5I. So the product in case of excess of HI will be 2 times of C2H5I. Once it is formed here, and this one will also get converted to C2H5I. Okay. So that was there in the 5 marker questions. Easily you can select any 4 and you can get 20 marks here. Now if you have done the Brahmastra series properly. Now coming to numericals, they were also very easy except one question. All other questions were direct and formula based. The first question is time required to decompose SOCl2 to half of its initial concentration is 60 minutes. Means T half is given to me 60 minutes. Okay, and it is also given that if the reaction is first order, so N is equal to first order. So what I have to find? Rate constant. Very simple question. We know K is equal to 0.693 by T half. So I will substitute that one, 0.693 by 60 minutes. So if I solve this, answer I will be getting is 0.01155 minute inverse. Okay, this was a easy question. Easily you can get 3 marks. Now coming to question number 42. This question I can find was little difficult. Henry's law constant for CO2 in water is given. Okay, that is 1.67 into 10 to the power of 8 Pascal. Okay, next calculate the quantity of CO2 in 500 ml of soda water when packed under 2.5 atm, okay, and 298 Kelvin. So we know that this formula of Henry's law, what does it tell? Pressure of the gas is equal to Kh into solubility. Now why I am writing solubility? There is a reason. Now see, in general solubility we express in terms of mole fraction, but sometimes based on the question we can express the solubility in terms of molarity as well. Okay, so in this case we will be explaining solubility in terms of molarity. Now if you see here, convert it into pressure to Pascal. So we know 1 atm is equal to 10 to the power of 5 Pascal, right? So that means 2.5 into 10 to, so I can write what is the solubility. Solubility will be equal to P by Kh, or I can write for P 2.5 into 10 to the power of 5 divided by 1.67 into 10 to the power of 8. So this if I solve, I will get around 1.156 into 10 to the power of minus 3, because it is what? Molarity. I am taking moles per liter. Okay, now what we have to do? Now you can find, okay, now we know molarity. Okay, now molarity is equal to what? Number of moles by volume into 1000. So I can say what is number of moles? Volume into molarity by 1000. So if I just substitute that, volume is 500, molarity is 1.516 into 10 to the power of minus 3 divided by 1000. Okay, so if I solve this, number of moles I will be getting is around 7.58. Okay, so that is equal to 7.58 into 10 to the power of minus 4. Now question is to calculate the quantity, means you have to convert it into mass. So to convert it into mass, what you have to do? You multiply with the molar mass, 44 gram per mole. So that will give you around 0.0334 grams. Okay, fine. So that is about 42 question number. 43, the conductivity is given, kappa value is given 0.0248 s centimeter inverse, and concentration is given 0.2 molar. You have to calculate what? Molar conductivity. That is equal to kappa into 1000 by C. So we know kappa is 0.0248 into 1000, right, divided by C is 0.2. So if I solve this, you will be getting around 124 s centimeter square mole inverse, and this was a direct and easy question. Now moving to question number 44. This is also easy question. A solution containing 18 gram of non-volatile electrolyte solute. So what is mass of the solute? 18 gram. Is dissolved in 200 gram of the water. So this is WB solute. WA solvent mass is 200 gram. And the water freezes at 272.07. So this is your TF, that is 0.07. T naught F is 273 Kelvin. Okay, then we have KF value, which is equal to 1.86. Okay, so now what you have to find? The molar mass of the solute. So we have a formula here, delta TF. Okay, or I can write T naught F minus TF is equal to KF into molality is what? W2 by M2, sorry, 1 second, yes, so it is WB by MB into 1000 by WA. Okay, so what will I get here? T naught F is 273 minus 272.07 is equal to KF 1.86, WB is 18 gram, MB into 1000 by WA is 200 grams. So now if I solve this, you can find the molar mass, which is around 182 gram per mole. Okay, that is very easy and direct question. Next is your electrode potential. Standard electrode potential for Daniel cell, E naught value is given to you, that is 1.1 volt, and calculate the standard Gibbs free energy for the reaction. Okay, so you can find from the reaction N is equal to 2, so delta G is equal to minus NF E naught of the cell, so that is minus 2 into 96500 into E naught of the cell is 1.1. So if you solve this, you will be getting around minus 1212.3 kilojoule. Okay. Now coming to the last question, this was also easy question from kinetics. The rate of a reaction increases by 4 times. Okay, so I can write K2 is 4 times and K1 is equal to K. Suppose when the temperature is raised from 340 to 360 Kelvin. Okay, calculate the activation energy. So we know this formula, log K2 by K1 is equal to EA by 2.303 R, okay, T2 minus T1 by T1 into T2. So if I just solve this, it will become what? Log 4K by K is equal to EA, I have to calculate. Next 2.303 into 8.314. T2 is what? 360 and this is 340 divided by 360 into 340. So if I solve this and you calculate the value, EA will be around 70.5 kilojoule per mole. So all the numerical questions were very easy except the one, the second question, that is your 42. Other all questions were very easy. So 9 marks you can score this. So that's all students in this video, and I will be just wanting to know how was your paper, okay, which questions you find difficult. But yes, one thing I can guarantee you, that if you follow my Brahmastra series and Decode NCERT and Chakraview series, then definitely all the questions you will be able to attempt. Okay, so you can easily get 60 plus if you follow these particular series, because I am doing extensive work on this, all the questions I am covering, and very soon I will be covering coming up with a video where all the pre-board papers from different districts, I will be giving the difficult questions from all these papers. Okay, so that's all in this class. Thank you students, and I hope that you will not forget to subscribe the channel. Okay, and see you soon in the next class.